All right. So we wanted to start a new unit. We kind of got a little tired dealing with trigonometric functions, learning what is complementary functions, complementary trig functions, what is the role of different angles, how do we extend from basic trig functions, leverage unit circles to deal with bigger angles. And we are moving on to the next unit that is called circle theorems. Now, before I start, anybody in the class who is comfortable with what is a circle theorem, can you brief me about it and help me recall? Otherwise, I have forgotten everything. Anybody? What do you mean by circle theorem? What does it do? What is that it covers? Anybody? See, your teacher is old. He can forget things. You guys have to help me recollect. Now, where is Davik and Sahit? Arus, any idea?
No.
Okay, don't worry. Okay, so anybody can brief me about what is a circle theorem if you have come across it? Or what does circle theorem do, where it is used? Praneeth? Ban, Ritika, anybody? Yep, Praneeth, go ahead.
I think it's like the different, like, how lines interact with the circle to create different, like, angles and stuff like that.
Okay. Samriddhi, any thoughts, beta?
No.
No? Jana, Kusi, anybody? You guys are relying heavily on your teacher? Okay, all right. Yeah, you need to. Teacher's job is to make you guys aware of what you need to be aware. So when we talk about circle theorem, so it is primarily to deal with certain behaviors and properties of a circle. And whenever you come across a circle, the first thing that comes to your mind is circle is a shape which is derived by only two things. One is what is the radius. Bigger the radius, bigger the circle. Smaller the radius, smaller the circle. So knowing the radius of a circle is very important. And where is the center of the circle? Where is the center located? If I'm talking about this as my coordinate plane, this is my center. Center remains the same. So here, center is different from the origin of the coordinate plane. There could be a situation where center of the circle and the origin of the coordinate plane also coincides. There could be a situation where your coordinate plane is lying somewhere here. This is your coordinate plane and your center is here. So net, when we are dealing with circle, you just need to know, Lovishwa. So kids who have joined just now, we are talking about circle theorem today in the class. And what I was saying was, a circle theorem I'll come to later. But whenever you talk about a circle, there are only two things that is important for us to know. One is what is the radius of the circle, and second is where is the center located against the coordinate plane. Okay, and that is what derives each and everything that we need to know about a circle. Is that a good starting point, Jana, Samriddhi, Ritika, anybody? Everybody okay? Biswadev, everybody? Yeah. Okay. Now, circle theorem is an extension of what we know about a circle already. So, circle theorem says there are certain very unique things about the circle or certain unique properties of a circle that we should be able to derive by knowing about the circle better. So let's list down some of those basic traits or properties of a circle, and that we will lean on for dealing more with it. So first thing first, a circle makes 360-degree angle at the center, or if you are measuring that in radian, it makes 2 pi radian at the center. Is that okay? Everybody? Kushi with me? Arush? Okay, alright. So that is the first thing, that a circle makes an angle of 360 degree at the center. So what I mean is, if this is my circle, this is my center. If I rotate around the entire circle, this angle from here all the way till here, this angle is 360 degree if you are measuring in degree, and if you are measuring in radian, it is 2 pi radian. Simple. Now let's look at some more things. So we know about the radius. If I extend the radius and cut the circle into half, that is the diameter. So that you guys already know. Now other things or properties of a circle that you guys would probably know are perimeter of a circle, for which you have already learned the formula. It's 2 pi r. This is the perimeter. And the last thing about the circle is the area, the space that it takes on the surface where you're drawing it. That is pi r square. Up to this everybody is okay, right? Everybody is comfortable? No problem? Okay. Yes, Arush. You're saying okay?
That was good.
Okay. Jana, Khushi, Neil, Sarah, everybody with me so far, right? Vishal?
Yes, sir.
Okay. Now, there are certain terminologies that will come across a circle. Now let's look at the circle. This is the circle, and I just mentioned that the perimeter, meaning the entire boundary of the circle, is nothing but 2 pi r. If I cut a small piece of it, this is called arc of a circle. So the entire perimeter is nothing but the arc, but that covers the entire circle. Here I'm talking about cutting a portion of it. Yeah, this is called arc. So arc of a circle. Now the question is, how big is the arc? How do we relate that with the 2 pi r? That circle theorem tells us. Okay. I mean, again, there is no theorem, full-blown theorem that we have, but we will use the understandings that, I mean, all our understanding around the circle to derive this. Okay. So one is called arc of a circle. Now let's kind of go a little deeper into it. This is my center of the circle. So if I join this point and this point with the center, so there are two radiuses or two radii. How do I pronounce it? Radii, right? R-A-D-I-I. R-A-D-I-I. How do you pronounce it? Hello, Saranya. Do you guys know how to pronounce it? R-A-D-I-I. What happened? Everybody is quiet. Am I disturbing your nice sleep after lunch? Ananya, Ved, yeah, Praneeth. What is that called?
Radii.
Radii. Okay, I'll call it radii. Or let's not stress ourselves. We have two radius, this radius and this radius. And if you want to define what is an arc that we're talking about, an arc is the length along the perimeter of a circle between the two radius or two radii or whatever. Forget about it. Okay, so arc is nothing but, arc is the length between 2 points on the perimeter, which is between the two radiuses. Okay, so you will, when you see a smaller length, see again, these are the two radius. This is one radius. Let's give it a name. OA and OB are my two radius. So we are seeing that, okay, this is my arc, but there is one more arc that we are overlooking right now, which is this side of the perimeter. So you see, this will be your minor arc, and here to here, if I use a different color to make it more visually appealing, we are seeing a major arc also. Is this okay so far? So Saranya, for you beta, we are just talking about circle theorem, and we are currently looking at certain properties of circle that we already know or knew, and now we are trying to see what does circle theorem do. So circle theorem helps us deal with arc of a circle, sector of a circle, and the central angle of a circle. So we just started talking about the arc. So that is where we are saying that arc is nothing but a portion of your perimeter, and how you derive that is meaning there are two radius OA and OB. Between that you have part of the perimeter that is called arc. If you are looking at the smaller piece, that is a minor arc. If you are looking at the larger piece, that is a major arc. Is that okay so far? How we will derive it, we'll come to it. But yeah, everybody okay? Ritika, Ria, Vishal, everybody? Okay. So basically, you see, now what we are doing is we are looking at a broader perspective, meaning if I have a circle and I picked up 2 points on the perimeter, meaning if I join the center with those 2 points, there are 2 radiuses that is defining the boundary or the length of the arc. There is one which is minor arc, one is the major arc. But again, we are only measuring the length along the perimeter. How about this colored portion? I have used black and green markers. Let me use a blue one. Any idea what is this one called? The shaded portion, the blue one. Yes, Pradeep.
Sector.
It's called sector. So basically, we have looked at what is arc of a circle. I mean, we have just tried understanding what exactly it is. How do we calculate it, figure it out? And we looked at sector. So basically, if you pick up 2 points in the perimeter and join that with the center, the shaded area between those 2 lines is called sector. So again, same way, if you want to look at it in a broader perspective, you'll say this is the minor sector, and this one, the other side of it, is the major sector. So basically, your sector is analogous to your area part of it. Your arc relates more with the perimeter of the circle. Does that make sense? Yeah? Yasmita, Sarah, Neil, everybody? Arush? Yeah? Alright. Vivan, okay? So basically, there are 2 things that we talked about, arc of a circle and sector of a circle. Now let's look at the third thing, which is nothing but the angle. These 2 lines are making angle. So this is the angle called central angle, meaning the angle made on the center of the circle by those 2 radiuses. Now things are becoming much more clearer. If we were not talking about this angle, then we were saying this is the minor arc, this is the major arc. This is a minor sector, this is a major sector. But then as soon as the angle, the central angle comes into play, it makes it more specific. It doesn't give us 2 options. It says, now this is about my point blank way of calculating arc. I'm not talking about minor or major arc. If this is the angle, then I'm only confined to talking about this part of the arc. If this is the angle with respect to which I'm doing all my calculation, I'm talking about only this area, which is my sector. So there are 3 things that we'll talk about when we talk about circle theorem. Circle theorem is nothing but a concept that helps us relate our perimeter, angle and area of a circle with respect to a smaller portion of it. Is that okay? Everybody okay? Alright. So now you will come across situation like this. Okay. Yes, Mita, okay, beta? Ananya? Ritika, everybody? Khushi has been very quiet, but I'm assuming everybody is able to follow me so far. If I'm blabbering, if I'm moving fast, if I'm rushing for concluding something, please stop me, okay? Jenna is always first to respond. That means she is paying attention to what I'm doing and she has no doubt. If there's any doubt, anybody, please don't hesitate. So now, let me give a simple situation that you'll deal with. Somebody says, you have a circle of radius 10 centimeter and the central angle is 60 degrees or pi by 6 radian. Find out the length of the arc length and the sector of the circle. And I just cooked up this problem on the fly. So this is just a situation, okay, that I'm kind of stating in front of you guys, that if you come across a situation like this which says, okay, you have a radius of circle given as this much, central angle is 60 degree or pi by 6 radian, find out the arc length and sector of the circle. Can you guys give it a try and tell me how much it is? And I would want to hear from you guys, how did you calculate it? I'm just giving you guys 5 minutes before I take you all to some legitimate questions that you will come across. This is more like a jump start. Or at least tell me, how would you calculate it? And you all have only 2 minutes. Not to calculate, just to tell me what is the approach before I jump onto some actual interesting problems to deal with. Yes, Praneeth.
Is it 60 degrees or?
I'm sorry?
Is it 60 degrees?
Yeah, it's 60 degree or pi by 6 radian. Oh, no, it's not pi by 6, it has to be pi by 3. No, right. I mean, you might come across a question in radian or you might come across a question in degree. That's why I'm putting both of them together.
Yeah, so to solve for the arc, you would use your circumference formula, 2 pi r, and then multiply that by 60 divided by 360 because you have 360 degrees inside of the circle, and then 60 by 360 would give you that portion. Multiply that by your circumference formula to get the arc, and then for the sector it'd be the same thing, except instead of circumference formula you would use your area formula.
Okay, cool. That is the way to look at it. Now, question to everybody. Samriddhi, Vivan, Saranya, Khushi, Arush, did everybody follow what Praneeth said?
Yes.
Everybody clear? You don't need a teacher. Praneeth is good enough. No, Praneeth is good enough. All of you are good enough. I'm just... See, apart from teaching you guys math, my goal is to also kind of navigate you guys towards becoming a storyteller. I don't want you guys to tell stories which is not relevant, but when I say I want you guys to become a storyteller, what I mean is I want you all to be able to articulate what you know and how you want others to know it from you. Okay, so that's why I keep on bothering you guys to tell what you think, how you would explain something to me, with me being a least intelligent person on this earth. Okay, not because I'm trying to prove anything. My goal is to see how we can explain something in the simplest possible way. So Jana, Saranya, everybody followed what Praneeth said? Okay, Ananya also, wonderful. Now, even if Praneeth said so, I want to secure my job. So let me do the same thing again. Okay, so here, like Praneeth explained, the way he probably envisioned this was that, okay, fine. If I'm talking about arc, I'm talking about one portion of the entire perimeter. This is the arc, A to B, this curve. So if I'm talking about AB, the arc, I'm talking about a portion of the entire perimeter. What portion? This arc length is determined by how much angle it makes on the center, or what is the central angle. If this angle becomes bigger, arc becomes bigger. It keeps becoming bigger, the central angle becomes bigger, arc is becoming bigger. And by the time it comes and hits this point, meaning when it touches 360 degree, I'm talking about the entire circumference. So 360 degree is equal to the entire circumference, which is 2 pi r. But right now we are only talking about a small portion of it, and which is making only 60 degrees. So 360 degrees is equal to 2 pi r. If I talk about it, the length of the arc for 1 degree, it will be 2 pi r divided by 360. If I am talking about 60 degree, I will multiply this whole thing by 60. So that is how Pradeep said 60 over 360. What portion of the perimeter? 60 by 360. Had it been 360 degree, I was talking about the entire perimeter, I am talking about only 60 degrees. So that is how this ratio is derived. And this will not only hold true for arc, this will hold true for your sector also. If I am looking at the entire area of the circle, I am talking about this angle to be 360 degree. Right now I am only looking at a piece of the pizza or a pie, and that is making only 60 degree out of 360. So 60 out of 360 times the area, that is what will give you the. So this will give you, you will replace r with your, and the radius that is given, that is 10 centimeter, that will, whatever it comes out to be, right? So you will find out that thing as a length of the arc. Same thing, area of a circle, you know, is nothing but pi r square. So take pi r square for 360 degree. So for 60 degree, it will be 60 divided by 360. A portion of the entire 360. That is what we are talking about. Everybody okay with that? So I did not do anything magical. I just repeated whatever Praneeth said, okay? I copy pasted it. Now let's look at some problems. Real world problem, because this was a cooked up one. Let's look at some real world problems that you will come across. Some standard problem which might look similar or different from this. And then we will see how we are solving those problems. So we are going to break our head with some of those problems in the next 35 minutes that we have. Now hear me carefully, okay? So let me first do my magical drawing. This is given as 9, and this region is kind of shaded. So let me shade it. Okay. Then the question says the circle has center O and a radius of 9. If the area of the shaded region is 5 by 12. If the area of the shaded region is 5 over 12, area is equal to 5 over 12. What is the area of the unshaded region? If the area of this region is 5 over 12, what is the area of the unshaded region? And then you are given options as 9 pi over 4. This is option 1. Your option 2 is 21 pi over 4. Then the option 3 is 135 pi over 4. And your option D is 189 pi over 4. So I'm repeating the question one more time. The question says, this is a circle where the radius is 9 and O is the center of the circle. It says if the area of this shaded region is 5 over 12, what is the area of this unshaded region? And now it's getting interesting. I want you guys to think about it, try solving it, and we will see how we are progressing with this. And if anybody gets stuck, raise your hand. I'm here, your friends are also here. But give it a try. Again, one last time. You are given a circle. This area of the shaded region is given as 5 by 12. You have to find out area of the unshaded region, and the radius is 9. Let's see what is that you guys are getting to. Only clue I can give you is you are given the sector, probably the minor sector. You have to find out the area of the major sector of the circle. Is everybody clear about the question at least? Kushi, Saranya, Samriddhi, Jana, everybody clear about the question, right? Riya, Pranit, everybody? Go for it. Go for the kill. And again, I don't want to do something which makes Pranit cry or some of you cry, but apply RAN, okay? Read the question again, which we have done already. Analyze, think about it, okay? Don't jump onto solving it. Think about it first. You will be able to find the clue. Yasmita, clear beta? Yasmita is angry with me. Dev, Kushi, Neil, everybody, give it a try. Okay, you guys have 5 minutes to deal with it. And I'm keeping it time boxed so that you guys can solve this in a time sensitive manner. Riya, you are trying it, beta? Yanil.
We're supposed to find the area of the unshaded area?
Yep.
So, and 5 over 12 is the area of the...
Shaded one. Yep.
Okay.
So just letting you all know, some of the kids who come to the classroom, I meet them in person. This last week rather, I had an opportunity to meet Neil and Sarah in person as well. Though they never come to the class, but I could meet them in person. Okay, I'll go muted. I'll let you guys deal with it for next few minutes. Anybody? Still working on it? Yes, Ritika.
Wait, like I know like the approach to like solve it, but like I didn't like get like a solution. So like, nothing.
Okay.
So should I like say like the approach that I'm like using or?
You can say it, but I'll probably make you wait for a couple of minutes.
Okay.
The reason being, I don't want anybody to get influenced by your thoughts. I want everybody to break their head once. Okay? In the meantime, while we are waiting for everybody else to come back, you can probably see if that approach is helping you get to any of the options. Okay? Yes, Samriddhi, you were saying something?
I got D.
You got D. Okay. How about Ananya?
I also got D.
You also got D. Okay. Dave.
I got D, sir.
You also got D. Okay. Arush.
Yeah.
Sorry, beta.
Yeah, I got D.
You also got D. How about Saranya, Yashmita, Jenna, Khushi, Neil, Sara, everybody? So, I'm giving you guys one more minute, okay? Just to conclude it. And if it's taking a little longer, that's okay. But we will hear from Ritika, Ananya, and Samriddhi, and Arush. Yes, Mita. Tell me, Mita.
I also got D.
You also got D? Okay. I will randomly pick a name, okay? I have no preference among you all, okay? You all are same for me. But I'll just randomly pick any name to explain to rest of the class, including me, okay? All right. Who was the last one? Yasmita, do you want to explain it? How did you get D? How did you get D? Or Ritika, okay. Ritika did not give me the answer, but she said she can explain the solution. So Ritika, do you want to explain what would be the approach?
Yeah, I can like say like what I was like thinking.
Mm-hmm.
So like at first like I thought like you would like find the area of like the whole circle because like the radius is like given.
Uh-huh.
So you can use like pi r squared and like find like the area of the whole circle. And then
Okay.
you can like multiply it by like 5/12 to find like the area of the shaded region. And then you can like subtract like that amount from like the total area like at the end. And, like,
Okay.
so the numbers are- I
But
think.
now I want to bother you better. So since you knew the approach, tell me why you were not wanting to get to ABCD.
I don't know, like I didn't really like I was like getting like I didn't like get like that. So maybe I like did like a calculation like wrong because I didn't like get one of those.
Okay.
It's like,
Hi Tony. You got a little late, but okay.
yeah, sorry.
It's okay. And you were one of the kid in the class who was very regular being with me in the classroom, but of late you are also being remote. I would want you guys to see in the classroom more often, okay? Before it gets super cold. And even if it gets super cold, I have enough heaters in the classroom, okay? Don't worry about it. I have put already one heater, I'll get 2 more. So don't worry about the temperature, okay? Alright, but yeah, I mean, I feel more comfortable when I see not you in particular, but all of my kids in the classroom, okay? Alright. So, Ritika told the approach. Ananya, do you want to say anything different from what Ritika said before you got your answer? Or you think it was the same approach?
I kind of got the same approach.
Same approach. Dave or everybody same? Jenna, go ahead, beta.
I have a question.
Hmm.
Why are we multiplying the total area with 5/12?
We are not multiplying, okay? Because I will anyway solve this problem. But see, the only information we have from this question is this is the circle and this is the radius given to us, 9. It doesn't say the unit. So quickly for Tony. So Tony, since you joined late, today we are talking about circle theorems. And circle theorem is nothing but some tricks and techniques that we need to apply on the top of what we know about circles, like knowing the perimeter of a circle, which is 2 pi r, knowing the area of a circle, which is pi r square, and knowing that a circle makes 360 degree. There are 3 new terms that we'll talk about more often. One is called arc, which is a portion of the perimeter, arc of a circle. And right now you are seeing a shaded region. This is called sector of a circle. So one portion of the whole area, okay? So, and the angle that it makes on the center, that's called the central angle. So there are 3 terms that you'll come across. And as part of circle theorem, we are not learning any new concept. We are just relating it with what we know about circles to find out different things. So this question was that there is a circle given to us and the radius given is 9 and there is no unit given. So let's assume whatever you want to assume, be it centimeter, inch, whatever you are comfortable with. So radius is given and also says the area of the shaded region here is 5/12. We have been asked to find out what is the area of the unshaded region. Okay? Does that describe what we are trying to do, Tony? Okay. So now coming back to Jenna. So Jenna, we are not multiplying anything, okay? Now let me do that in the simplest, easiest form, okay? And right now I'm running very low on IQ. Very, very low. Okay? That's a very commonly happening situation that I deal with. So we know that, okay, this is a circle and this is, the radius given is 9. So let's find out what is the area of this. And again, if I apply my RAM technique, we have read the question enough, I'm analyzing it right now. The question is saying, okay, this is radius given and this is a shaded region whose area is given this. So what we have to find out is the area of the unshaded region. So if from the radius I can find out the entire area and this area is given. So from the entire area of the circle, if I subtract this part, that will give me this area. That's what we are trying to find out. Is that making sense to everybody? Jenna, Neil, Sarah, everybody? Jenna, is that a good starting point? We are saying that from the radius I can find out the area of this circle and this area is given. So out of the whole area, if I subtract this area, then I'll get the area of the unshaded region. Does that make sense? Okay, so now let's find out. So I have the radius given to me, so we can find out the area of the entire circle, and then this area is given. So it's all about subtracting this whole area. So let's find out the area of the circle. So my rand said analysis is simple now. Whole area minus this area. Okay, let's do it. Now I am putting on my Nike shoe. So area of the circle is equal to pi times r square, which is 9 square. This is 9 times 9 is 81, so 81 pi is my total area. Now it says this area is 5/12. And was it 5/12 or 5/12 pi? Let me just confirm one more time. It says 5/12. Okay, now this, I'm not sure if I missed something when I was reading it. I'm reading the question one last time. It says if the area of the shaded region is 5/12 the area of the circle. It says it's 5/12 the area of the circle. So whatever is my area, it is 5/12 of that. So area of the blue one, okay? I'm not sure if you guys consider that or you just blindly followed what I said. I made a mistake. It says 5/12 the area of the circle. So whatever is the area, the blue area is nothing but, let me not draw a triangle here. The blue area is 5/12 of the area of the circle, which is 81 pi. So the area of the unshaded region would be 81 pi area of the circle minus this whole thing, 5 over 12 into 81 pi. It's as simple as 81 pi is common in both the terms. It becomes 1 minus 5 over 12, which will be nothing but 7 over 12. 12 minus 5, 7 over 12. So 81 pi into 7 over 12. 81 into 7 over 12. So 12 is, it becomes 27 into 3 is 81 into 7 into pi divided by 4 into 3. So this 3 and this 3 gone, 27 into 7. 7 7 is 49, 7 to the 14 plus 4, 18. Yeah, D is the answer. So I think I made a mistake when I was reading the question. I did not mention that area of this is 5/12 of the whole area. I mentioned 5 over 12. I should have been more explicit saying this thing, but I believe you guys interpreted this correctly and you treated this as a 5/12 of the entire area of the circle. So now Jenna, you were saying that why are we multiplying by 5 or 12, right? That was your question. Because the question says the area of this circle is 5/12 of the whole area of the circle. I mean, area of this shaded region is 5/12 of the whole of the area of the circle. So this was the area of the circle, 5/12 of that. That's why we are multiplying. Does it make sense, everybody? Yes, Neil. Yeah, Jenna, you're saying something. Yeah, go ahead.
Wait, can you explain that again for the multiplying, please?
Yeah, sure. So here there is no math. What it is saying is area of this shaded region is 5/12 of the area of the circle. Okay, that is a statement. 5/12 of area of the circle. So whatever the question is saying, I am reading that in English and writing that in English only. 5/12 of is same as multiplication. Okay, 5/12 of this. If I say I will take half of your money, okay, so what do I mean by that? I'm saying let's forget about you all knowing half of anything. I'm saying I'll take half of your money. Let's say you have $500 in your pocket right now. I'm saying I'll take half of your money. Okay. Same way, it says 5/12 of area of the circle. We found out the area of a circle. What do we need to do for finding area of a circle? If you have a circle, if you know the radius, you will do pi times r square. That is your area. Plug in r with the radius given to you and you get the area. It says 5/12 of the area of the circle. So whatever is the value coming from the area of a circle, 5/12 of that. So multiply that by 5/12. Does it make sense? Everybody clear? Tony clear? I know you started a little late, but I'm hoping that I'm able to break it down into simple terms. Yeah? Kushi, Yashmita, Dave, everybody clear, right? Okay. Now, let's jump on to the next problem. And this time I will make sure that I don't commit similar mistakes like what I did with this problem. Okay? And probably when I'm making mistake, then also that's becoming an opportunity for all of us, right? That reading the question is very important because that makes your life much easier. If once you guys practice a lot of problems, right? Whenever somebody says 5/12 of the area, okay, you'll say okay, 5/12 of the area of area. See, any area you're talking about. If somebody says 5/12 of that is done, meaning you're talking about this of area is the remaining one, and one out of, when you're subtracting 5/12 from this one, mentally you will be able to say, okay, so 5/12 is already this one, so remaining one is 7/12. So you will just do 7/12 into the area, which is pi into r square, and you'll be very quick with your calculation. So all that will happen with practice. We took 2, 3, 4 minutes for solving it, but once you guys practice a lot of problems, right, these kind of mental calculations will make your life much more interesting and solution the problems much more quicker. Okay, so let's pick up the next problem. Let's look at the next one. I have a question on the similar lines. Pranit, okay? You did not say anything.
I don't think so.
Okay, all right. No, I have the habit of nagging kids, right? I'm a very bad teacher for all good reasons. So, this is the question. Next question. There is a point given name C. There is a point given name A. And this is the center. When you join C with the center and A with the center, this is given a name O, and it says this angle is 250 degree. See, 250 degree. The circle has a center O and a radius of 36. Radius is given as 36. What is the length of the minor arc? Okay, it says this is a circle, radius is given as 36, this angle is shown as 250 degrees. We have been asked to find out the length of the minor arc, and the options that we are given are 12 pi, 22 pi, third one is 50 pi, and the fourth one is 60 pi. I'm reading the question one more time so that I don't commit the same mistake. This is a circle with the radius given as 36. This angle is 250 degree. There is a point given here saying B. I don't know what is the relevance of that, but I'm making sure that I'm copy pasting it perfectly. It says the circle has a center O and the radius 250 degree. What is the length of the minor arc ABC? What is the length of the minor arc ABC? Now I think it's making it more explicit. ABC. See, whenever somebody says minor arc, you're always looking at the smaller one, any which way. But the question is more explicit by saying, what is the length of minor arc ABC? That means it's saying, find out this length. Yes, Pradeep.
B 22 pi.
22 pi, okay. Everybody heard the question?
Can you repeat it one more time?
So you see a picture on the board, right? This is a circle. This is point A, this is point B, and this is point C on the perimeter of the circle. Okay? And the radius of the circle is given as 36. And this angle here is given as 250 degree. The question says, find out the length of the minor arc ABC. So ABC. So it's explicitly saying, find out this length from here to here. Is that clear, Sarah?
Yes.
Okay. Go for it, everybody. Khushi, Tony, Ananya, Ritika, Saranya, everybody okay? Yasmita, Dave, Tony, okay, wonderful. Go for it. I'm giving you guys 2 minutes to deal with it. It should not take more than that. I'm not trying to create pressure here, but I'm saying that is the time you will allocate to yourself for solving this kind of problem. So Noah, you have joined 8 minutes early. You'll end up learning circle theorem, which will be a little too much for you. Okay, so join after 5 minutes, okay? 5-6 minutes, or maybe 8 minutes to be precise. I have one interesting problem to deal with, okay? I would want that problem to be done as well. So that's why I'm giving you a little less time so that we can deal with that problem as well today. Let me use the wait time for drawing it. Okay, anybody being close to being done? I got an answer from Praneeth. Praneeth said he's leaning on B, right, Praneeth? Okay, Ritika, Saranya, Sara, Neil, Harush, Dev, anybody? Kushi? Yes, Jenna, go ahead.
I got 22.
22 pi, right?
Yes.
Yeah. Okay, so let me rush through this quickly, okay? I know, sit down, you're here, but you're not here. All right, so here, this question is saying this is 36, this is 250 degree. We have to find out the length of the wider arc. So, total angle is 360 degree we are talking about. This is 250 degree, that means this angle is 360 minus 250, that is 110. Rudraj, don't make any sound. I said there has to be pin drop silence. It's only voice to be heard right now. So, if we know this angle, then we can find out this length. Now, length of the arc is what? If it was 360 degree, meaning the whole thing, that would have been 2 pi r. And r is by 36. So, 36. But we are talking about only 110 degree, meaning one portion of the entire perimeter. So 360 degree is equal to 2 pi r, which is 2 pi into 36, that is 36 into 2, 72 pi. 360 degrees translated into 72 pi, the entire perimeter. We talk about only this portion, 110 degrees. So 1 degree will be to 72 pi by 360. So if you are talking about 110 degree, you multiply whatever coming for 1 degree with 110. This 0 gone. 36 times 2 is 72. So 11 into 2, 22 pi. That's it. Yep. Rudraj, I said no sound please, because when I hear those sounds, that gets me distracted, okay? Is everybody clear about it? It was not a big deal. It was just about how do you visualize this? How do you break it down that, okay, entire angle is 360 degree, talk about only 110 degree. That is how this length of the arc is what will come into play, correct? So if 360 degree, what is my whole length? If I'm talking about 110 degree, this will be my whole length. I believe that is how Jenna, Praneeth and everybody who was close to being done would have got it, right? So what I would do is, there's an interesting problem here, okay? I want to read this problem, make sure that you guys think about it, and then we'll probably pick up this problem in the next class. Let me read it right now. As you can see, there's a circle, and this is a point D, there's a point C here, and there's a point B here, okay? I think it's B is this point where this line is. intersecting the circle. It says in the figure, point O is the center of the circle. The line segment AC, this line segment AC is tangent to the circle at point C, and OA from here to here is 12. If the arc length of the major arc BDC is A times pi, what is the value of A? So let me read this question one last time. You see a circle here. This is B, this is C, this is D. It says AC is a line that is tangent on the circle at point C. And the length of OC from here to here is given as 12. We have been asked to find out, length of OA, length of OA from here to here is 12. If the arc length of the major arc BDC, so BDC is A pi, what is the value of A? And this is an interesting one. That's why I wanted to flash this question here on the board. When you guys watch the video of the class, look at this picture one more time and think about it. That is when we'll get to deliberate with this question in the class tomorrow. This is one of the questions. Obviously, we'll have more. But these are all related concepts. So far, we know about area of a circle, perimeter of circle. Those things are easy. But how do we relate those concepts and extend that for further, relating with other shapes and understanding of geometry and all? That is what circle theorem helps us with. Okay, that is where we talked about arcs, central angle, and also the sector of a circle. Okay, with that being said, I will let you guys go. Take a quick break, think about it, and we'll deal with this more in the coming class. All right?
Bye, sir.
Bye, bye.
Bye, sir.
Bye-bye.